So this session will be interesting since we are going to perform the hydraulic calculations for wet sprinkler system. So our topic will be sprinkler system hydraulic calculations. If you want to know the manual calculation procedure to perform the hydraulic calculations, you can watch on my YouTube channel Irfan CFPS. So coming back to the calculations, initially you need to make one format to prepare a summary sheet. Since we need to put all the data in the summary sheet which were considered in our hydraulic calculations. So just I am showing you a sample format here. However, each company has their own format, or any individual can prepare their own format, but they need to add few points which I am showing it here. For example, you need to add the hazardous area for which you considered to perform the hydraulic calculations. For example, if I am having a ground floor, first floor and second floor, obviously second floor will be the remotest area from the pump room, and in second floor which room or which particular area you considered, or which particular area you considered to perform the hydraulic calculations, that room name has to be mentioned in the summary sheet. Classification depends upon the application of the building. NFPA 13 has provided a list of buildings or list of applications. Based on that, we can finalize the occupancy hazard classification. For instance, for office building, we will consider light hazard. For hospitals, we will consider light hazard. All this information can be found in NFPA 13. So design area of operation for light hazard we already discussed in our earlier classes. It will be about 1500 square feet. Rate of application or the density for the light hazard is 0.1 GPM per square feet. Since we have taken an example for light hazard occupancy, we are entering those details here. And what are the considerations which we are going to consider in our calculations will be the sprinkler K factor 5.6 and number of sprinklers considered in the hydraulic calculations are 10. So in the summary sheet you need to enter these data. These are the minimum data which you need to provide so that the reviewer can understand what exactly you have considered to perform the hydraulic calculations. So total demand requirement will depend upon the hydraulic calculation results. So we are going to mention it here. The total water requirement as per the hydraulic calculations, including host stream allowance at starting node, will be X GPM at Y PSI. So why we are adding host stream allowance to the sprinkler demand? Because as per NFPA 13, if it is a light hazard occupancy and we are doing the calculation for sprinkler system, we need to add at least 100 GPM to the sprinkler demand. If it is an ordinary hazard occupancy, then we need to add 250 GPM to the sprinkler system demand. For example, if the hazard occupancy is extra hazard, then we need to add 500 GPM to the sprinkler system demand. This is NFPA 13 requirement. I will share you NFPA 13 2019 edition via email so that you can just access that and find these details over there. So as per NFPA 13, please remember, whenever we perform hydraulic calculations for sprinkler system, we need to add host stream allowance to the sprinkler demand. See, upon reviewing the drawings and preparing the design drawing or shop drawing. Before entering the data in the Elite software, we need to prepare the isometric based on the hydraulically most demanding area or hydraulically design area. For example, as you can see on your screen, we have considered 2-floor building here, ground floor, first floor and second floor, and these sprinkler systems inside the building are served by fire pumps. So we have a dedicated fire pump which we are considering in our particular project, and the sprinklers are served from the fire pump. So initially, based on the type of system, type of hazard and design area of operation, we are going to design the sprinklers in the hydraulically most demanding area. In case of light hazard, it is 1500 square feet. So initially we are going to design the sprinklers or distribute the sprinklers only in the remotest area, to the design area. So for light hazard occupancies, we will consider 1500 square feet. For ordinary hazard occupancies also, the design area will be 1500 square feet. For extra hazard occupancies, the design area is 2500 square feet. So for OH group 1 and group 2, it is same 1500 square feet. For extra hazard group 1 and group 2, it will be about 2500 square feet. So based on NFPA 13 standards, we are going to distribute the sprinklers in the design area. So this one basically we call it as hydraulically most demanding area. Since it is on the second floor, so hydraulically most remotest floor and hydraulically most demanding area. So now coming back to the isometric, once you have prepared the isometric, you need to enter whatever considerations you have done. Those points, at least you need to mention these points, whatever I am showing on the screen should be entered on the isometric drawing. So the type of system in our case is wet system, type of hazard light hazard, design area 1500 square feet, type of sprinkler we are going to consider standard response. If you want to consider quick response sprinkler for light hazard or ordinary hazard occupancies, then the design area can be reduced from 1500 square feet to around 900 square feet as well, because I already discussed in our previous sessions, if we consider quick response sprinklers, the design area of operation can be reduced from 1500 square feet. But if you are considering standard response sprinklers, then this is what NFPA 13 asks for. So the sprinkler K factor will be 5.6. We are going to consider in our calculation, and the above ground pipe I am considering carbon steel schedule 40, and for the underground pipe I am considering HDPE SDR 11 PN 16 rating pipes. So underground pipe, whatever pipe you are going to consider, those details has to be mentioned on the isometric, so that the reviewer can easily identify and understand what are the exact considerations you have done in the calculations. So after mentioning all these things and after providing the isometric, this has to be done in AutoCAD. We are going to put the node numbers. So before mentioning the node numbers, I'll just try to explain you. We need to mention the pipe sizing as per the pipe schedule method. Here you can see on your screen, we mention the pipe size as per the pipe schedule method, and then we need to mention the length of the pipe as well. For each pipe we need to mention the length of the pipe. After that we can add the node numbers, or maybe you can add node numbers in the first shot, and then you can put the dimensions and also the pipe sizes. However, this isometric need not be in scale, so we can make it as not to scale. Just we will put the exact dimensions as per the shop drawing or the design drawing. So now after that we are going to put the elevations for all these particular pipes. So for example, here if you see, our pipe is coming from the underground. So this is the ground floor, and on ground floor we have considered a reference point as 0, 0. From here the elevation we have mentioned as 23.5 for this particular main line, and the branch line for the sprinkler will be on 24 feet, and it will drop to 23 feet. This 23 feet means this sprinkler will be installed on the false ceiling. So this orientation represents pendant type sprinkler. If you have upright sprinkler, there will not be any false ceiling. So below the slab or roof we are going to put the sprinkler. So basically you need to create this as well. You need to mention the elevation levels as well. Elevation levels will be considered based on some reference point which is 0, 0. I will explain you later. So now coming back to the isometric. Now we have mentioned the nodes. For example, we have started the nodes from here. So from the pump I considered nodes like 1, 2, 3, 4, 5 and so on. Otherwise you can consider from the remotest sprinkler as well. For example, you can consider this as, or this as 1, 2, 3, 4, as you like. Node numbers need not be, node numbers need not be any particular format. We can consider as we like. So I mentioned node numbers from the pump set. So since we have electric, jockey, diesel, so I am considering only one pump, because hydraulic calculation software doesn't know whether it is an electric pump or jockey pump or a diesel pump. Just we need to enter the pump data which we are going to select. So just we are just mentioning like pump set. So now 1 to 2 will be always pump nodes, or this node numbers, as I already told you, can be changed to some other 700, 800. Node numbering we can mention as we like. So for example, here I consider 1 to 2 for the pumps, and then here I mentioned like 3. Since the elevation is changing from 2 to 3, I mentioned, see here the elevation changed from here, so that's why I mentioned the node number. So node numbering, basically we need to mention at few locations. For example, if there is an elevation change, we need to put the node number. If there is any pipe size change, so here we have 4 inch, see here 3 inch, so we need to put the node number if there is any change in the pipe. Otherwise we need to put at each tees, not otherwise, we have to put at all the tees which are considered in our calculation. So this is the T, so we have mentioned the node number here, here and here. Everywhere we mentioned the node number, and for this we have mentioned for elbow as well. So how many number of nodes you mention, you need to enter all those node numbers in the Elitefire software. So now if you see here, 1 to 2 fire pump, and node 3 will be this one, and node 4 I consider this as reference 0, 0. From here the pipe is going underground. Underground pipe is about 4 feet down from the 0, 0 level. So here I mentioned like node 5, and it is running, see here it reached to the ground floor. So I mentioned at this particular point node 6, and again 0, 0 level, the pipe raised, so we mentioned like 0, 7, and from here we are just moving, see here I mentioned node number 8. If we want to know the pressure at particular point or particular node, we need to mention the node number. If we don't want to know the pressure at a particular point, we can neglect this node. But since we have first and second floor, I just want to know what is the pressure available when the pipe crossing the first floor zone control valve assembly. So just I mentioned like 08. So node number 8 I mentioned here, node number 9, and from here node number 10 I mentioned here. Okay, but the pipe size is 3 inch and 3 inch. It's fine. But no need to mention if there is no change in the pipe size. No need to mention this node number as well. So 9 to 10 and 10 to 11. Here I mentioned like 12. No need to follow any particular sequence. These node numbers are only for our understanding and our reference purpose only. So 11 to 12, 12 to 13. Here we can mention the node number, but it's not required since our concern is about the sprinkler. So here we mentioned like 14. Here this node will be 15. Here it will be 16. Again from 11, see here 17 we mentioned. So in this way we need to put all the nodes 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So there are total 36 nodes we have shown in our isometric. All these nodes has to be entered in the Allied Fire software. Enter edit pipe data. So now how we are going to enter these details I will explain you in few minutes. For example, we are starting from 1 to 2. Either you can mention 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and so on in the Allied Fire in this sequence, or you can mention like 36 to 35, 35 to 33, 34 to 33, 33 to 31, 32 to 31, 31 to 28, 30 to 29, 29 to 28. So beginning node, end node, beginning node, end node, beginning node, end node. In this way we can mention as we like, but we should not miss any particular node which we have mentioned it here in the calculation. So we are going to consider this particular isometric for our calculation for sprinkler system. Here what I have done, I have just modified the node numbering. Since I already told you we can change the node numbers as we like. So basically once we finalize the isometric in the AutoCAD, we need to enter all the data manually in Allied Fire software. So now if you look at here, see I have considered this as node 1, node 2 and I continuously taken all the nodes till I reach the fire pump starting point. So this will be the inflow node. Please remember this will be the inflow node. Now what we are going to do, we will enter all the data in the software. So the result will look like this: sample project, fire sprinkler report for XYZ company and prepared by, we can put someone's name, representative name, and here month or date we can mention as we like. So this is the report. We will check the software as well, but before we are going further into the software, just I want you to understand the report so that you will get an idea before proceeding ahead. So whatever data we mention in the Allied Fire like general data, it will be shown here. See the approval agency I mentioned as civil defense, and system data or project data, whatever we mention in the general project data will be shown here. So for light hazard we mentioned like design area 1500 square feet. Sprinkler system will be wet type. It is not shown here, but we need to mention like wet or dry. Since in our calculation we consider as wet, it will be shown it here as wet. Maximum area per sprinkler will be 225 square feet for light hazard. Schedule 40 pipe is the default material. Outside host stream allowance will be 100 GPM since it is a light hazard. We will mention like the sprinkler size half inch and the temperature rating of the sprinklers. And if we have any test flow data, or if we are going to take the tapping connection from the existing tying point for our new building or new system, then we need to do the flow test, or we need to perform the flow test, and based on those results we need to mention the test flow rate, static pressure available and test residual pressure available at the tie-in connection point. Since in our project we have a dedicated fire pump, so this will be kept as 0 only. So based on our inputs entered in the software, it generated the system flow rate as 371.41 GPM and the inflow residual pressure as 67.47 psi. So we have run our calculation in demand mode. So in demand mode we are telling to the software that I need 7 psi minimum residual pressure at the remotest sprinkler. So automatically the software consider and provide us the required demand and pressure to reach the 7 psi pressure. And here you can see number of active sprinklers as 10. We have mentioned 10 sprinklers in our calculation, so it is showing here. And the minimum desired flow density will be 0.1 GPM per square feet. So now here you can see 67 psi and 371 GPM and 7 psi here. So we'll go back to the isometric. So I told the software that I need 7 psi at the remotest sprinkler. So what will be the required pressure at the inflow node? Then the calculation software provided me the results with the required demand such as 371 GPM and 67 psi. If I have at 37 node or the inflow node, then I can achieve 7 psi at the most remotest sprinkler. So my system demand will be 371 GPM at the rate 67.4 psi. So based on this we can finalize the pump capacity. However, if we have in our project fire hydrants, fire hose cabinets or landing valves, then we need to calculate for each and every system the required flow rate and the required inflow pressure. Then we need to finalize the fire pump capacity based on the higher demand and based on the higher residual inflow pressure at the starting node. So basically here from 10 sprinklers we are going to get, or the outlet flow will be about 271.41 GPM, but it is showing 371 because we told the software that we need 100 GPM to be added to the sprinkler demand. So 271 plus 100 will be 371 GPM. So we got this result. So this is the input data. Wherever we have sprinkler, it is showing sprinkler and K factor 5.6. Whatever we mention in the software, it will show here. So going back to the input data, which we already discussed in our earlier classes. Beginning node 1, end node 2, 1 to 2, 2 to 4, 3 to 4, 4 to 6. In this way we have mentioned all the nodes till the fire pump. So 37, 36 is the fire pump node, and the pipe description we selected as 4 for schedule 40 wet steel. So it is showing in this manner. But for underground piping I mentioned like HDPE, HDR 11, PN 16. So the C factor for this as per NFPA 13 will be 150. So based on that, the software has shown whatever we mentioned as input, it is shown in the report. So now if you see the pipe size, whatever we mentioned in the pipe input data, it is shown here, and whatever fittings we entered there, that also has been shown here in the report. So from this report we will be able to know whatever we enter into the software, that will be shown here. So nominal length length of the pipe or length of the pipe from node 1 to node 2 will be 3 feet, node 2 to node 4 will be 14 feet. These are all we have mentioned in the data software. So now going back to the output data, we got some output data from the software. However, the most important thing to be checked in the results will be in the last page. So this is the hydraulic graph. Here we have shown the fire pump curve and the required demand, sprinkler system demand, along with the hose trim allowance is shown here. This diagonal line is the sprinkler system demand. This straight line is the hose allowance, which we consider in our calculation. So obviously we consider 500 GPM 65 PSI fire pump, and this is the curve for 500 GPM and 65 PSI, and our results show that whatever is our system demand or system requirement, such as 371 GPM at 67 PSI, is under this pump curve. So we can go ahead with this fire pump. So here you can see whatever fire pump data we entered for the fire pump, it is shown here. 500 GPM 65 PSI fire pump, 750 GPM is the 150% of the fire pump capacity, and 43 PSI will be the 65% of this 65 PSI. At zero flow it should be 120%, or as per NFPA 13 it should be 140% of this particular head. So since we consider demand curve or demand mode, so the calculation shows in this way. Residual pressure, so this will be the pressure required at the initial node 67.47 psi. Calculated flow rate or sprinkler water demand including hose allowance is 371 GPM. Exterior hose flow, which we entered for outside hose trim allowance as 100 GPM, it is shown here. So now going back to this particular output summary page, this is also most important. Here we need to check couple of points. First point is related to the velocity requirement. As per NFPA 13, for above ground pipe there is no limitation for the velocity. However, as a standard practice, we can consider maximum velocity as 20 feet per second. If our calculation is less than 20 feet per second, here if you see it is 17.42 feet per second. So we are assured that this is fine. But if our velocity requirement which we get from the calculation is more than 20 also, no need to worry, since NFPA 13 does not prescribe any limitation for above ground piping. However, for underground piping you need to check NFPA 24 for velocity limitations. As per my knowledge, there is no limitation requirement for underground piping. So you can see this is the first point which we need to check, and second one will be the GPM from one sprinkler. You can see here, and residual pressure, we told the software that I need 7 psi at the remotest sprinkler. It calculated based on our noding data and all those things as 16 psi. Since sprinkler can withstand about 175 psi, so this is fine. Okay, and our requirement was 7 psi. It is more than 7 psi available at the remotest sprinkler, so this will also be fine. So in next session we are going to look at the allied software so that it is easy for us to understand each and every point. I hope you understand everything. Let me know if you have any queries through my email ID. Thank you so much once again. Bye.